Good afternoon. Evening, guys. Uh, Anybody to the past paper? The past paper first section, the I and the triple I.
Yeah.
Can you tell me the answers again for them? Just want to see if I'm right. Just want to see if I'm right.
We get 5 for the first one and -9/9 for number 3.
Yeah, the last one kind of confused. You know, for the
Good afternoon, students. How are you doing today?
Afternoon, sir.
Where we did our class again, please?
Repeat, sir.
Where were we the last class again?
So you gave us two questions to do.
I gave the questions to do from the past paper, right?
Yes, sir. The December 2018 past paper.
Okay, good job. Thanks for the reminder. Okay, so technically I'm finished with the I'm in 24 the reminder. Okay, so I know where I'm at now. Okay. All right, so we're going to start some differentiation today. The same area that you guys were giving me for the solution of the topic that I gave you last class, the homework. I didn't look at that because I didn't teach you the area yet. So I'm going to teach you some first principles today, and hopefully I can move from first principles into the rules of differentiation. But before I do, let me go to the 2018 paper, and let us look at the questions given, and let us see if we can attack those questions. I'm checking to see if I know how to do them, and we will take it from there. Did we all do the questions? Is there anyone in the class that never did a question? Can somebody answer me, please?
Did the question? I think everyone did the question, sir.
You think who?
Sir?
You're saying you did the question? What you're saying?
So I said I think everyone did the question.
Okay, great. I'm happy for that vote of confidence. All right, let us look at question number 1. Because really and truly, I am not going to spend much more time on these. Question number 1, part 1. Part 1.
I can't tell you what I did, sir.
I'll go right ahead.
All right, sir. So I substituted the negative 3 for the x,
Good
and
job.
I got 25 for the answer, sir.
Good job. Excellent. So the limit as x tends to -3 of the root of, as it goes to 3, so it'll be 2 times -3 squares plus 7.
So it's 2 times 9 plus 7, which is
2
25.
times 9 plus 7, the root of.
Yeah.
So that is going to give me 18 plus 7.
Yeah, that is equal to then 25.
25.
Which is equal to 5.
Good job. And how many marks were those? Oh, 2 marks. Yeah, okay. Easy 2 marks. The other question is a little
The third one.
different because you recognize this 5 marks?
Yes, sir.
It's going to require a little bit more, but not impossible. Part 3, give me half a second, please. Half a second. All right. Number 3. Boy, number 3 kind of look ugly now, but let me do a different color for number 3 since I have so many. All right, so this one says the limit as x tends to -3 again of x
Color
squared
looks
plus.
really poor, man.
Say it again.
Color looks really.
Oh, you don't like the color?
Color looks poor. I didn't see it.
So the limit as x tends to -3 of x squared plus 6x plus 9 all over x squared plus 3x. All right, so it's not going to infinity. So it says once you see a numerator and denominator, chances are it may be indeterminate, but this one not going to infinity, so I can't divide by anything, but because it's going to -3, so we must always substitute. So I'm going to go ahead and do what my teacher says. This is going to be -3 squares plus 6 times -3 plus 9 all over -3 squares plus 3 times -3. That works out to be 3 3s 9. 3 6 are 18 minus 18 plus 9. Whoa, that looked like it turned to 0. And 3 3s 9 again. And plus minus 9. Whoa. What do we call this?
Is that the undefined?
Indeterminate.
Indeterminate.
It's indeterminate. All right. I don't want to say you're not too far up time, but I don't want to say undefined. I want you to say indeterminate. Undefined has a different meaning. So I want you to say indeterminate.
No.
All right. So it means that there's something inside of something that is causing something to not work or something like that. Oh, I recognize x squared plus 6x plus 9 to be the perfect squares. Anybody recognize that? 3 plus 3 is 6.
Yes, sir.
Yeah, man. So I'm going to get the limit as x tends to negative 3 of x plus 3 times x plus 3. Students, you must at this point be able to look at stuff and identify those that are perfect squares, those that are the difference of squares. And in the denominator, I recognize that I can factor some x, so x into x plus 3, talk truth.
Yes, sir.
So I cancel one of those, cancel one of those. So I'm going to be left with x plus 3 over x. And what?
0 over minus 3.
They're going to be minus 3 plus 3 over minus 3 down. So you're going to be equals to 0 over minus 3 down. What is that answer? What's the answer?
Zero, sir.
Thank you, sir. Answer is equals to 0. 0 over minus 3 is 0, not undefined. Undefined is only when it equals the 0 exists in the denominator. So 0 over minus 3 is 0. How we stay, how we feel.
Very good.
Right?
Easy 5 marks for me.
Easy 5 marks. Matter of fact, I wouldn't say that, you know. I'd say easy 10 marks. 5 plus 3, 8 plus 2, 10.
Okay.
Yeah, man. Easy 10 marks, man. Not difficult. We can't do we can't do part B, but we did part C already. I gave a part C when I was looking at points of discontinuity. This was one of the homework questions, I believe. And we can't do anything here so yet. And the stationary points we don't reach yet. Integration we don't reach yet. We don't reach those yet. Differentiation is where I'm going to go to now. So I'm going to do this topic now. This exact topic, first principles. So at the end of this class, we can come back to this paper to answer this part A question. So far we've gone 10 and 16 marks. So by the time, before the day ends, we're gone 22 marks. All right. And yeah. Oh, yeah. So Nancy was a blank page, so we can do the rest of workout on this. All right. So let me just save this one so I can come back to it.
I'm not sure if this is in previous classes, but when not really midterm.
Say it again.
Are we doing midterms next week or?
Closer to the end of the class, we can have that conversation. Closer to the end. Remind me though, before you know, don't let me leave it out.
I remember I discussed it before. I just wasn't present.
Oh yeah, man. Yeah, and I don't remember if we discussed it in this group. I know I had a conversation in my pre-calculus group, but towards the end of the class, the session, just remind me, Taj, that we have some housekeeping to talk about. Let me just. You know what? Let me talk about it now, because I don't want to have to rush into it. All right, so I'm going to say to you, I have not yet prepared a date in my headspace. The mid-semesters have already been prepared. What I'm going to ask you to do is to use this weekend, this long weekend, to start your preparations. Everything that you've done so far is going to be tested on your mid-semester. All I'm going to ask you to do is just to make sure that you go through every single thing. Make sure you go through every single thing. I prefer to give the mid-semester on a Friday Reason being, we have 3 hours, and I can give the mid-semester in the last, say, hour and a half of the session, instead of having to rush on a Tuesday when it is that you have a 7 to 9 class. How does that sound?
Makes sense, sir.
All right. So, so can we agree then that next week, Friday, not exactly this time, but maybe about 6 o'clock-ish, thereabout, we will be doing our mid-semester?
Hey,
Wait, so you mean we're gonna do the mid semester first and then we're gonna continue class?
Say it again?
So you mean we're gonna do the mid? Oh, never mind.
Okay.
but sir, that works. That works for
Okay.
me.
Yeah, man.
Has any other input?
Right. Good. So if there are any changes, any unforeseen changes, I will definitely communicate with you. Tuesday, God's willing, when we return for class. Remember, we'll come back to class on Tuesday, all right?
Okay, sir.
Okay, good job. All right, so please make sure that you get your preparations in and out of the place. All right, so let me just clear this. Oh, come on. I'm sure I saved it. I don't want to lose the solution here. I'm sure that I saved it. Let me click on save again. Do you want to replace it? Yes, I would love to replace it. All right, so that is save. All right, let me go now to, all right, buckle up. We are, we are ready to begin a new area. We are ready to begin a new area, and that is going to be first principles differentiation. First principles differentiation.
Sir?
Yes, please.
Sir, is this why you're about to start going to also be on the test or everything before this?
Everything that I will be doing. So yes, this will be included as well.
Okay, sir.
Mhm. Something that I'm going to start and finish in class tonight. So that's why I want you to buckle up. So how am I going to be teaching this topic? I'm going to be teaching this topic by doing.
Me not cut you, sir.
Uh,
Yeah, so how would I do this? No book or what? Or
all right. So it's going to be done on paper, or you can do it in your book. Doesn't really matter for me. What is going to happen is that you're going to be doing it, and then you're going to be scanning those photographs. You're gonna scan the photographs and send the scan document as an email. But there are some things I should be working on by now and then, so I will give you further information on that. But yes, you're going to be doing your work in your booklet. No, your
Okay,
cameras
sir.
must be on. Your cameras must be on. And when I say cameras must be on, I'm not talking about cameras on and all I'm seeing is also top of your head. I need to see that you are doing your work, your own work. Students, I'm telling you, if I see any level of collaboration, and I won't tell you the ways that I will see the collaboration, but if I'm seeing any levels of collaboration, if I run your paper through my software and I'm seeing assistance from these AI stuff, you're going to be heavily penalized to the point where you may end up getting a 0. It's not going to help you. Study, prepare yourself, because when you go into the final exam, it's just you and Jesus alone. All right? You've been warned. I don't want to apply the full brunt of what I have accessible to me. All right? So I'm just going to ask that you do what is required of you, and we'll be fine. Okay. So I'm going to be doing this topic by giving you an example. how do I do this now? So we have a function in front of us. So as you see here, as I put it, the prerequisite knowledge is going to be on algebra. The prerequisite knowledge is going to be on algebra. We're going to be using quite a bit of algebra in order to tackle this topic. If your algebraic skills are weak, you're going to be having some problems. If your algebraic skills are up there, you'll be fine. All right, so that formulation in red is very important. The limit as h tends to 0 of f of x plus h minus f of x over h. All right, so this is like you cooking some soup, for argument's sake. And I want you to pay attention to this plus h. This is you cooking some soup. Whatever soup it is. But to the soup, you're adding some scallion, pimento, rosemary, celery, thyme. But when you say that the soup is finished, let me ask you a question. Would you serve the soup with the thyme stalk in there or the scallion head in there? Yes or no?
No, sir.
No. Presentation-wise, it not look good. So what it is that we're going to be doing now is removing all of those seasoning. Removing all of those seasoning. Now, what has happened is you're putting it in there for a purpose. Once it is that it has fulfilled the purpose, you're removing it. Look at my f of x plus h. I'm looking at an incremental change in f of x. I'm looking at an incremental change in f of x. So I'm investigating, I have my f of x, and I'm going to have that incremental change in f of x. And when I've done that incremental change in f of x, then I'm going to go back f of x, all of it. And what is left is going to be the rate of change. And then I'm going to divide that by h. Then I'm going to divide that by h. So what I'm doing is looking at my incremental change. So every time I write an f of x, I'm going to put a plus h because I'm investigating that incremental change. When I finish with that, and I do my little algebra, my expansion, and fix it up there, so then I'm going to remove all of what I originally started with. And in this particular example, I'm then going to remove the 2x squared minus 5x plus 3. So what is left is pure stuff. It is going to be pure stuff. Are you following me?
I listen, sir. I listen.
All right, let's go. So the question says to differentiate 2x squared minus 5x plus 3. Every time I write my x, I'm investigating the rate of change. So I'm going to put a plus h to it. So see, I have my 2, watch it. See my 2 here. Then I have an x squared. I'm investigating the rate of change of x, of h. It's going to be an incremental change. So I'm gonna add my plus h. So this is going to become now not just x, but x plus h. See it here? X plus h. And then I'm going to square it. Why squared, sir? See the square up here, sir? Every time I write an x, I'm going to put the plus h. I'm investigating that rate of change. Then I'm going to put this minus 5. See here? Minus 5. But sir, see x here again? Yes. I'm investigating my incremental change. It's going to be x plus h. See here? X plus h. then my plus 3, my plus 3. So all of this is representing my f of x plus h. Tell me, do you see what it is that I've done right here?
Yes, sir, I see it. What about that negative one?
No, don't worry about it. Just look on the part here first. The rest of you see how I get this here?
Yes,
Yes,
sir.
sir.
I understand where you get the negative.
Good job. Watch me now. Minus f of x. Now, what is f of x? F of x is all up here. So you notice I said I was given the function. I was given something to say. 2x squared minus 5x plus 3. And then I say let f of x be equal to all of this. Let f of x be equal to all of this. All right? I'm letting f of x be equal to all of that. Watch me now. I'm now going to subtract the 2x squared minus 5x plus 3 here. Boom, minus. And I'm going to put everything in parentheses. Sir, why do you have to put it in parentheses? Because of this negative sign is going to control this term, as well as this term. And all of that is over h. So I've now completed all of that. So watch me now. This x plus h all squared. I'm just going to give you a little recall to refresh your memory. Just for now, x plus h all squared is the same thing as x plus h times x plus h. X plus h times x plus h. Now, what I want you to remember is how it is that we distribute, how we FOIL. X times x is x squared. X times h is hx. H times x is hx. And h times h is h squared. I have only one x squared. I write it back. I have hx plus hx to give me 2hx plus my h squared. Do you all see that?
Sir?
Yes, sir.
All right, good. So I can therefore substitute my x plus h all squared now for x squared plus 2hx plus h squared. Look at what I'm doing. That's exactly what I did. I'm substituting all of this for this that I've just worked out. If you recognize, I'm putting at the minus 5 times x plus h right here. Then my plus 3 and everything else that is there, I put back here. All that I'm doing here for now is just putting this x plus h all squared. The expansion of it, that is. Then I am going to start the distribution. What I mean by that, sir? 2 times x squared gives me 2x squared. 2 times 2hx gives me 4hx. 2 times h squared gives me 2h squared. Finish with that, move on to the next. Minus 5 times x is minus 5x. Minus 5 times h is minus 5h. Plus 3. Minus 1 times 2x squared is minus 2x squared. Minus 1 times negative 5 is going to be a positive 5x. Because when I multiply two negative numbers, I get a positive number. And negative 1 times positive 3 is a negative 3. Still over my h. Pausing. Are you following? Are there any questions?
Continue, sir.
Sir, can I ask you to go over that part again?
Which part?
Sir, the 2x square after
This?
yes, sir.
So I'm distributing this 2 over all of here. 2 times x squared is 2x squared. 2 times 2hx is 4hx. 2 times h squared is 2h squared. Minus 5 times x is minus 5x. minus 5 times h is minus 5h plus 3 minus 1 times 2x squared is minus 2x squared. Minus 1 times a negative 5x is a positive 5x. And the minus 1 times 3 is a negative 3. Let me know, Kahim, how you still know.
Yes, sir. I'm fine.
Okay. Is there anybody else?
Sir, so you said that minus one would represent the F?
No.
Yeah.
That minus one is just this negative sign that is outside here.
You just a placeholder, sir.
It's just a placeholder. Yeah, that minus sign is this minus sign here, but I just want to say minus times a negative 2 because raised a minus 1. Yeah, it's just a placeholder.
Okay, sir.
All right. So now, when I do that, I recognize that this negative 2x squared can be cancelled with this 2x squared. You remember I said to you that I cook in the soup, I add in my thyme and my pimento, and then when everything finished now, I'm going to take it out. You remember that? See it right
Yes,
here,
sir.
See it right here, so now. So I don't cook the soup. Me now want it in the pot now again. Minus 2x squared, cancel with minus 2x squared.
All right.
Positive 5.
My question to you. Why is the 2x cancelled, but they're not divided or separated by equal sign?
Because the signs are different. They are opposite signs. 2x squared minus a 2x squared is 0. This negative
Oh, you group
5x
them and solve.
plus a
Oh,
5x.
okay.
Yeah, man.
Just like you
And
group
this,
and solve.
right, and this positive 3 cancels out with this negative 3. And the question to you is, it will always happen like that.
Yes, sir. It's true. You just can see kind of throw me off a bit. So realize you just group them and solve them. It's like terms are, yeah.
So what is going to happen? See here now? They cancel. So it's me putting in f of x plus h minus f of x all over h. So it's me subtracting all the stuff in there. One minute, please. All right. Any other questions so far? So look at what is happening here now. Now, hold on a minute, please. All right. So what is going to be left is going to be 4hx plus 2h squared plus this negative 5h all over h. All over h. Follow me? Right here?
Think so, sir.
Okay. Now, let me just point out something here. If I substitute h is equals 0, you recognize that it's going to have 2x squared right here.
Repeat, sir.
If I substitute h to be equals to, if I apply the limit right here, so now, and substitute h equals to 0 right here.
Sorry, the person not moving, so I know exactly where you're talking.
If I substitute h equals 0 right here, do you agree with me that I'm just going to have 2x squared?
Yes, sir.
And if I put h equals 0 right here, do you agree that we have only minus 5x?
Yes, sir.
Good. And when I multiply this by -1, that means this will cancel with this right up top. And this negative 5x will cancel with this positive 5x. And I multiply this -1 by it. So we end up with 0 up the numerator. And if h equals 0, I'm going to end up with 0 in the denominator. So you recognize I'm going to end up with something that is indeterminate. Agreed? Good.
Yes,
So
sir.
that means I have to do some sort of working on rationalization, simplification, or factorization. All right. So it is following the same trend that we've been having, conversation that we've been having. So watch me now. Now that I've done some cancellations, it means that I would have isolated those areas that will cause the function to be indeterminate. So look at what I'm going to do now. Now it is that I'm going to substitute my h equals 0. Now it is I'm substituting my h equals 0. No, before I do that. And again, here, I'm showing that it's indeterminate as well. But before I do that here, if my h equals 0, I am going to get the same 0 over 0 because see a h right here, so a h right here, so and another h right here, so. So the truth of the matter is if I substitute h equals 0, this going to go to 0, that going to go to 0, that going to go to 0, and so it does this one go to 0. So I'm going to end up with 0 over 0. So look at what I'm going to do. I'm going to do a factorization. I'm going to factorize my h from up top here. So I'm going to take out h is common to all the terms. I'm going to take out h. And I take out h, I'm going to have 4x left. When I take out h from here, I'm going to have 1h left. So I'm going to have 2h. I'm going to take out h from here, I'm going to have -5. Tell me if you see what I did right here.
Yes,
Yes.
sir.
Just
Yes,
take out
sir.
from each part of the equation. So.
Yeah. And then that is being divided by h. The h is cancelled, so all I'm going to be left with now is 4x plus 2h minus 5. Now I'm going to put right here, this is what I'm left with. Now I'm going to put h equals 0. Now I'm applying the limit. When I apply the limit, I'm going to get 4x minus 5. And the limit, this 4x minus 5 is now a constant. Sir, I see an x here, so it can't be a constant. It is. Why is it a constant? because this is h going to 0. There's no h inside here. So the limit of, as h tends to 0, of 4x minus 5 is simply going to be 4x minus 5. And this is going to be the answer to our question. It looks long. It really isn't long. It's just that it's our first question, and I was explaining to you. As you do these questions, they become easier. As you do the questions, they become easier. So let me minimize. Look at that, please, and tell me if you, as a review, and let me know if you are okay.
So sorry, in exam, if you don't know this formula, I will give it per sheet.
If we're going to know the formula to your head. But in a hard man, the limit as h tends to 0 of f of x plus h minus f of x all over h. The amount of questions we're going to do in class tonight, trust me, remember it.
All right, sir.
Sir,
Mhm.
there's no way to shine.
Yes, sir. There is no way to shorten. This is first principles, no way to shorten.
Sir, there's a second principle.
Is there all?
Second principle.
No. No, this is just first principles. First principle meaning that this is foundation, this is where it all starts. There are other methods. First principles again for limits was the intuitive method. First principles for the limits was the intuitive method, the intuitive approach. And now there are several approaches to it. All right, how it feel, how it stay?
Absorbing, sir.
Absorbing. All right, do me a favor.
Sir, may I write? It just reach.
Okay. All right, do me a favor. Shall we? Go ahead.
Sorry, I hear me.
Come on, go ahead.
So I was just wondering, could you go over where you got the 2hx in the first one? Where it says 2, we have x squared plus 2hx plus h to the second power.
X times x is x squared. X times h is hx. H times x is hx. H times h is h squared. There's 1x squared, so I write it back. hx plus hx is 2hx. There's only 1h squared, write it back.
Okay, sir.
So, you all have access to the 2018 paper, the same paper I was just working. I want to scroll on to question 4, and the 4A, I think it is, and the question that says, let's speak about the first principles. I want you to give an attempt to it, and then I'll work it in class.
When we finish right off, sir.
It's up to you. So just let me know what is happening. I give you a couple minutes.
Hi, sir.
Hi, how are you?
I'm good, sir.
Where you just reaching?
No, sir, I was just popping by, sir.
Oh, okay, yeah. I received your email. Yeah, big up yourself.
Thank you, sir.
Cool.
Yes, sir. 2018 past paper, question 4.
4A, yeah. Same people we're working just now.
Good evening, sir. You're sharing your screen?
Sir, which question is it from 2018 we should do?
Question 4A.
4A? Alright,
Yeah.
Was that Christian not seeing the screen?
Yes, my internet connectivity wasn't so strong, so it wasn't allowing me to see the share screen. So I kept on bouncing in and out.
All right, no problem.
Sir, we finished now. Check your chat.
Thanks, Alvin. How about the rest of you guys? Are you still working?
Yes, sir. I'm still working.
Just started, sir.
Still working, sir. What getting there?
All right, good job. All right, 3 more minutes.
What's your name if me correct?
I'm looking and I'm feeling like I'm teaching.
All right, sir.
Mhm. In the meantime, Richards and Green, look for some more past paper questions and start working on those for me, please. First principles, while the others are some work. So I'm giving you extra work. Congratulations. Love the answers.
All right, sir.
Cool.
Sir, could you check the chat?
Mr. Shan.
Yes, sir. Alright.
Can you please check the paper? 1B, part 2.
1B, part 2.
Yeah.
What about it? That paper you're talking about?
Yeah.
What about it?
I same thing that?
No.
Oh,
Mm-mm.
okay, was just wondering. Okay, thanks.
Uh-huh. All right, so I'm sitting here watching the chat. I have 16 of you. And 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 of you that gave me an answer. All correct answers. But there are 8 of you that have not yet communicated to me. Come on.
Sir, I'm still late, sir. I'm just but they're halfway, sir. So,
All right, take your time. The rest of you, please go to the past papers. What I'll do is,
So 2017 1B.
2017 1B. Do me a favor, let's
First part.
do me a favor, please. Share that paper again in the chat for me, please, so I can just project it instead of me having to do that. I appreciate it. All right, so those of you who sent me messages, I've responded to all of them. All correct answers so far. Thank you, Leparno. I will. Okay, so 1B1 for question. All right, I'm not waiting anymore. 1B1 for question. Um, hmm. 1B1 for question for the first principles differentiation. So in this year, you got two such questions. Part B, part B1 is a first principles. Part B2 is also a first principles. But part B2 is using a different approach.
Sir,
Yeah.
sorry, sir. But it screen is saying question two. All right, oh, it changed now.
Right. So you know what I'm gonna do? Because you guys did so well on that past week of question a while ago. I'm gonna say how mature you guys are. Whoa, you could them question here. 5 and 5, 10 and 3, 13 marks. What you know? 13 and 10, that are 23 marks. Hey, look on question 3, guys. The only thing for question 3 is part C that I don't teach yet, parametric equation. But question 3, part A, 1, 2, 3, is supposed to can box at all. Part B is supposed to can box at all. 23 marks. 23 marks. So let's go. I know you can do part 1 of question 1B, but I'm challenging you. I'm challenging you to attempt B2 as well and to see how well you can get. Anybody who gets it right, there's a surprise.
Okay, sir.
All right. Start from it, please. Let me see who is this now.
But a B1 as well, sir, or B2?
B1 and 2.
And 2. All right.
So could you repeat the question we should do?
B, all of B.
Sir, check your chat.
Finish, sir.
Post the answer, please. Post the answer, please. All right, I'm checking that one. All right. I'm not getting as many of the responses for question 1B1. A few students have tried
Almost finished.
1B2.
Give me just that.
Repeat, sir.
I was saying
I'm
I'm
not
almost finished with 1B1.
1B1. Oh, I was just saying that I'm not getting as many responses for 1B1. Sorry. Continue working, please.
So I'm gonna go somewhere around from the calculation at the start. I will check it. And get someone who can.
All right.
Sir, I'm having internet problems. I'm getting kicked out every now and then.
Don't worry about it. We've been having heavy rains. And you're at home, right?
Yes, sir.
Yeah, I hear some students complaining that excess of fufu internet, but I want to tell them say it's everywhere because I'm at home and I'm getting kicked out. So, well, not kicked out of this class, but it's just the internet is just unstable. So I'm telling them it's not excess just system necessarily because we've been having heavy rain. So never mind. I'm very proud of you guys though. There are some students and that are having conversations in the WhatsApp group, live in the chat. And their answers are coming out to be correct. But there are some of you in class. I've not seen an answer for the first question. Neither have I seen an answer for the second question. So it means that you're just here and not here.
Sir, I thought it sent off. Wait.
Why, sir, part 2 look like headache?
Don't worry about it. I'm gonna do it. I have some students in the chat. Trying and giving me varied answers, varying answers, but
Sir,
I don't see
that
the correct one.
minutes. Give 3 more minutes. I did some research to find.
No problem. No problem.
By the way, your screen is black.
Sir, I sent it.
Well, I'm seeing his screen, so
Yeah, I'm seeing his screen. So I'm here.
Um, Ashanti, very, 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 very close. Ah, there you go. Now you've got me. Good job.
Sir, me da go say something, me no want keep nobody off track.
That's right. Don't say it yet. Don't say it yet. Good job. Guys, you are close. Not very, but close. You're close, Tice.
Sir, I'm stumped at this point.
You're what?
I'm stuck, sir.
You're stuck? Pull.
Sir?
Pull.
Pull?
Yeah.
Sir. Sir. So is it that we just go straight through with it? I don't know if
Say it
you
again.
overthink it to go straight through.
Say it again, Pop.
Sir, for the second one, is it that we just go straight through? Because laugh.
Don't worry about it. Don't worry about it. I'm gonna go now. I'm gonna go in after you. I'm just correcting something here that I see in the chat. All right, let me just ask a question now. Is there anybody in the class that is absolutely struggling?
Yes, sir.
I'm late and I never see your work.
Yes, sir.
Yeah, man, me reach late, sir. So
Try catch it. The question that
example alone, nah work out for me, sir.
sir, I never see your work, I just I work halfway you do and I try catch it. Halfway there, sir. I try catch the F of X. The second part.
What's the moral? What's the moral of this lesson then?
Try reach
Come.
class early.
All right.
Sir, we
Okay,
have
miss.
technical difficulties, sir.
No, never mind. You got the moral. All right, just get to class early. Never mind. I'm gonna go now. All right. Ashanti, I'm waiting on you now. Send you something. All right. Tice, you look like you give up on me. All right, let's go. Let's go. Let's go. You guys did pretty well on. Oh, Lordy.
Sir, you have to explain now?
Yes, I.
Can I get a couple more minutes, please?
Portion of screen.
Sir, I sent the correct one.
Okay. Huh. Okay. All right, so question 4. Let me do question 4 first. Let me do question 4 first. And I'm gonna do question 4 somewhere down here. So right. It says 3x squared minus 4x. 3x squared minus 4x. All right, so it's going to be the limit as h tends to 0 of f of x plus h all squares minus f of x all over h. So it's going to be the limit. Make sure you're writing all of what I'm writing. If you don't put the limit as h tends to 0 every time, you're going to be in problems. So the limit as h tends to 0 of f of x plus h is going to be 3x plus h all squared minus 4 times x plus h minus 3x squared minus 4x all over h. The limit as h tends to 0 of 3 times x squared plus 2xh plus h squared. Is sir, just write it down like that. That's where and how I expect you to get to. The stage I expect you to get to very soon.
Sir.
Yes, sir.
I swear me see 3x cube.
You swear it's a 3x cube?
Seriously, sir. And that may I work. That's why I did it so long.
I forgot check your eyesight.
Yes, sir. Me too old, I know.
Yeah. Don't worry about it. It's happens to the best of us. All right, so let's go. Yes. 3x squared plus 6xh plus 3h squared minus 4x minus 4h minus 3x squared plus 4x over h. Just a quick question. The ones who gave me the answer, was this the method that you guys used?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Am I correct so far?
Yes, sir.
Okay. I have to work with the teacher now because sometimes the teacher make mistake. Watch me now. 3x squared cancel with 3x squared. This negative 4x cancel with this positive 4x. So will it always happen like that? Every single time. You put it in, you take it out. The limit as h tends to 0 now of 6xh plus 3h squared minus 4h all over h. Those h's cancel. So I'm going to have the limit as h tends to 0 now of 6x plus 3h minus 4. So what is going to happen is going to be 6x plus 3 times 0 minus 4, which is going to be equal to 6x minus 4. Those of you who came late, I hope you saw what I did just now. By the time we finish with these stuff, guys, we will have the solutions of these past paper questions. Make sure you keep them. My solutions, when I'm naming class, this is mine. Make sure you're writing out from what it is that I have. So we've gone through, would have bashed 1, 2, 3 questions. We did part C already at some other point. And then now we did this one. Can you look through for me, please, and let me know if you have any challenge, any difficulty? Right, there's no
So
response. Go ahead.
the line was 3 bracket x squared plus 2x h plus h squared. Can you explain from this, sir? Well, the line above and then this, sir. Can we figure say it derived from the line above? So you're still not sure? Come on, answer them. Okay.
All right, so recall x plus 8 all squared is the same thing as x plus 8 times x plus 8. What we do is to say that times that, that times that, this times that, and this times that. X times x is x squared. X times h is hx, x8, same different. H times x is hx, and h times h is h squared. 1x squared, write it back. Yeah.
Tell you a lie, sir. I get it long time. Work it by myself a while ago, sir. But me assist, but nah lie.
You saw the cube, you saw the cube.
A cube, sir, that mash me up. I mean, I go around and I get some figure, I can't see some of them, and they are trying to break it down. I mean, I tell you the truth.
Hush.
Because I come to class late, I don't know what they did before. So I just work.
Never mind. You know the moral of the story now.
Yes, sir. So
yeah, no problem. All right, cool. I'm happy with it. Mason, you see that now, Papa?
Yes, sir. I have that part, sir.
Good. And that's all we're doing there. So we're putting something in it, and then now once we have the incremental change, then we're taking it out. Once we have the incremental change, then we're taking it out. All right.
And
so
that's the principle all the time, sir.
Every single time. Every
you just know when to substitute x plus h and the formula.
Oh, so the line 2 the way I have this, sir, that is a formula, we have to know.
Yes, sir. f of x plus h all squared minus f of x
Yeah.
over h. The limit that of h tends to 0. You must know that.
Got you, sir.
All right. Now, I'm doing, let me know if you're seeing the new one. Where are we? Okay. So so what I'm going to do here, I'm going to let f of x be equal to 5x squared minus 4x minus 1. So Mason, see it here now. So the limit as h tends to 0 of f of x plus h all squared minus f of x all over h. So it's a limit as h tends to 0 of 5 times x plus h all squared minus 4 times x plus h minus 1 minus f of x, which is a 5x squared minus 4x minus 1 all over h. So what I have now is a limit.
So hold on a sir. So the f of x that we are right in that parentheses is the question.
Original function. It's the original
Gotcha.
function.
Gotcha, sir. All right. Continue, sir.
So it's the limit as h tends to 0 of 5 times x squared plus 2hx plus 8. You see that I'm writing the same thing over and over, guys? So what I'm saying to you, Green, I'm saying to you, you don't have to worry about it because it's the same thing you're doing over and over. Minus 1 times minus 5x squared minus 4x minus 1 all over h. Then I'm going to expand the limit as h tends to 0 of 5x squared plus 10hx plus 5h squared minus 4x minus 4h minus 1 minus 5x squared. When I multiply two negative numbers, I get a positive number plus 1 all over h. If you look carefully at it, you'll recognize that this cancels with this negative 1 cancels with that positive 1, this one cancels with this. So technically, all of this will be cancelled. All of those will be cancelled. Remember, you're cooking a soup, you put in your seasoning, pimento, your thyme, your scallion. But when the soup done cook and you don't get where you want to get out of it, you have to back it out. Take it out. But that, you're not going to eat those. That's exactly what is happening to this function. You're putting your incremental change in the function to investigate what is happening there. And when you put your incremental change in it, once you've gone through your incremental change and you intertwine everything into it, then you back out your original function. You back out your original function. What is left is going to be that small change. What is left is going to be that small change. That incremental change. Small incremental change. And that's what it is that we're investigating. All right, let's go. So it's going to be the limit now as h tends to 0 of 10hx plus 5h squared minus 4h all over h. This is indeterminate. So you recognize if I put your h equals 0, you can get 0 over 0. So we're going to have is factoring out.
We have to write indeterminate, right? So
I won't kill if you don't, but I want you to recognize that it's indeterminate.
Okay, sir. And another question. In the formula where we substitute the original formula, is it okay if we just write back f of x? Because that's what it's equal to.
No, write it out because I want to see the cancellation.
Yes, sir. Write it out, man. After me the third part, we just substitute back. So I get confused. And then we just cancel it.
Okay.
Yes. So that could work.
No, before me answer you, show me where you're talking.
Yeah, those two sections you put in parentheses. So me I say just put f of x is substitution I part. We cancel and just writing back the original function.
So we will be cancelled. You just put back f of x right here, so?
Yeah, right now the parentheses we say will be cancelled. So I'm just write back f of x and then two parentheses. Now the second part we cancel. Write back the function.
You have to write out the function. You have to write out the function.
Okay, sir, no problem.
Yeah. If you don't write out the function, guys, you're gonna be in problems. It must be written out. All right, and this is going to be 5 times 0 minus 4. And 5 times 0 is 0. So you're going to be left with 10x minus 4. And that's your answer. That was the answer. Over 2x squared plus 1. Part 2. All right, I want everybody to watch this now. The limit as h tends to 0 of f of x plus h all squared minus f of x all over h. Given f of x to be equals to 2 over 2x squared plus 1. By the way, let me stop and ask, are you guys following what I'm doing?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Understanding when I'm teaching?
Yeah, man, I catch it.
Good job. Is there anyone in the class that is lost? Maybe half lost, totally lost, or somewhat lost?
B2 kill me, sir.
Don't worry about it. What do you know? That's what we do now. Say B2 is an issue, don't worry about it because that's what we do now. Somebody said, sir. All right, let's go. Hold on. All right, let's go. Let's go, let's go, let's go. So the limit as h tends to 0 of 2 over 2 times x plus h all squared plus 1 minus 2 over 2x squared plus 1 all over h.
That is what you did.
And that's what's supposed to be done. If you follow what is happening, remember we have to divide it by h. The function says f of x plus h all squared minus f of x over h. You can't change the formulation.
No, sir, that didn't have a problem with the formulation. It was just how to sort out the fraction part, the two.
Oh, okay. All right, so come work with teacher now. So now, so we can rewrite this now. I'm not going to have enough space in my thought. The limit as h tends to 0 of 2 over 2 times, you know what? Let me not. So we're going to work the numerator of the question. 2 into x plus h all squared plus 1 minus 2x squared plus 1. So we're working the numerator first. Working on the numerator first. What's the LCM?
2x plus 1, sir. Oh, 2x squared.
2.
X plus 2x plus 1.
Wait, so it asks for the numerator?
Sir.
What's the LCM? What's the LCM? No, it's not 2. What's the LCM?
Is it x squared, sir?
No.
Is it 2
Is it
2x squared
So
plus
the
1?
H dropping, sir.
You know,
Is it 2?
is it x, sir? Or 1?
for what? What was
The
the
X
question?
Oh, 2x plus h squared plus 1.
Incomplete.
No. So what it
Let me ask you a question. If I give you 1 over 2 plus 1 over 6, 1 over 3, 1 over 2 plus 1 over 3, what's the LCM?
6, sir.
How you know?
Multiply the denominators.
Multiple.
Look on something I have on. What's the LCM?
It's
4.
4?
If I take on a lunch money, you see, or take on a weekend money, you see,
Sorry, you know, I was going to say 4.
and I'm happy you didn't say it because that's not correct. One over 2 plus 1 over 3 LCM is?
So you'd have to multiply the 2x plus h squared plus 1 times 2x squared plus 1.
Duh. Yes, sir. That's why I asked the question the way I asked it.
So, sir, the first one, the 8x plus 8 squared plus 1, don't we factorize that out first and then do the multiplication? No.
So whenever you're given a question of this nature or format using the same first principles differentiation, but it is given in a fraction form, don't expand it out. Not yet, that is. Not yet.
Okay, sir.
Yeah, not yet. All right, let us see what we can do here. So the LCM here now is going to be into x plus h all squared plus 1 times 2x squared plus 1. How many times can 2x squared plus 2x plus h all squared plus 1 go into the denominator here? All right, the other
One,
time.
sir.
No, man. Just say 2x.
2x squared plus 1, sir.
Yeah. It's the opposite one. Oh no, remember for doing
Yes,
something, it's
sir.
the opposite
2x
one.
squared plus 1.
Yeah. And then now minus 2 times, which other one is going on? 2 into x plus h all squared plus 1 times.
Plus 1. Yeah.
All right, now, so what is going to happen is that 2 times 2x squared. Oh, and then the denominator now, the denominator, I'm going to multiply by 1 over h. I'm multiplying by 1 over h, the denominator.
Good evening, Dean.
Who's that? Good evening, whoever was
This is so you multiply the denominator by 1 over h.
1 over h, yes, the same thing as dividing by h. It's the same thing as, it's the same thing
I get
as.
that now. You bring back the denominator in it now. All right.
Right. So it's the same thing as dividing by h and multiplying by 1 over h. So den, shortening for denominator, because I don't have the space right there. So the shortening for denominator right here. So all right, watch this now. So I am going to see if I can do some rationalization. You know, this thing kind of look jumbled up, but never mind. You'll see many more of those questions. 2 times 2. So I'm distributing this 2. Did I say to you that this topic, what's a prerequisite for this topic? Anybody remember when I started?
Algebra?
Yes. You can believe it. You can see it now? Whole heap of algebra.
Yes.
So watch me. Don't blink.
Sure.
2 times view.
What do you think, sir?
All right, good. So 2 times 2x squared is going to give me 4x squared. And 2 times 1 is going to give me 2. Watch the next side now. Watch the next side. Because this 2 is distributing everything inside of here. So I'm going to have now 2 times this 2 is going to give me 4. So it's going to give me negative 4 times x plus h all squared. Talk truth. Negative 2 times all of this piece here, don't. You see that? So you can give me, good. But this -2 is also multiplied by this -1, this +1. So you're going to give me a -2, don't it?
Yes, sir.
All right. So for those of you who don't see it yet.
Yes, sir. We see that.
This -2, there are two terms inside of here. 2 times x plus h all squared is going to be multiplied by this -2. It's going to give me -4 times x plus h all squared. This -2 times this +1 is going to give me a -2. Follow me? Let me talk to me now.
Following, sir. Following.
Yes, sir.
Yes, sir. Yes, sir. There.
Okay, all right.
You doing anything with the denominator at this point, sir, or not yet?
Not yet, not yet. Not yet. All right, not yet. All right, let's go. All right, so let's go. -2 times 1 is -2. All right, so all of this now is going to be over 2 times x plus h all squared plus 1 into 2x squared plus 1. And I'm still going to multiply it by 1/8. So whoever just asked about the denominator, still 1/8 right there. So follow me now?
Yes, sir.
All right, watch this now. Please don't blink, don't blink, don't blink, don't blink. I'm gonna work out the numerator. I'm never ever interested, as I was saying before, to work out what the denominator is going to be. I'm going to leave the denominator as abstract as it came. The numerator, no, I'm going to work out. Don't ask me, sir, why not working out the denominator? Not interested. The numerator is what I'm interested in, and you will see why shortly. So I'm going to have 4x squared plus 2 minus 4 times x squared plus 2hx plus h squared. Tell me that you can see that. Can you see that?
Sir, you're still talking about the numerator, right, sir?
Yes,
Only
sir.
the numerator I'm working out.
Okay.
So now you're applying the formula, right, sir?
It's not the form. No. Yeah. No. Yeah. Yeah.
Really and
I cannot
truly
work
doing
it.
the
I
4x
can,
plus h squared.
yeah, I cannot working out that part now. Yeah.
The f of x, where you put the x plus
F of
a.
x. Right. Yeah.
Okay.
Yeah. Right. No, I know that part. You see, I'm interested in just writing about the denominator as it is. And let me just erase a piece of this. I think all of it going to go, but okay, no. And then let me just put back my 1/h. And then now, all of that is going to give me 4x squared plus 2 minus 4x squared. Can you see that? This -4 times x squared is -4x squared, don't?
Yes, sir.
Yes, sir.
And this -4 times 2hx is going to give me -8 hx, don't?
Yes, sir.
Yes, sir.
And this -4 times a positive h squared going to give me a -4h squared, don't?
Yes.
And then I'm going to have a -2 somewhere out here, so. And then I'm going to have my denominator, see? I don't know why they give you 5 marks for that, you know, because if it was me, but I give about 8 marks to this question, because it's not the same, discipline as the first one. The first one deserved the 5 marks. So if you see a
This
question
question alone, sir, equal every marks on the paper.
Say it again?
This question alone equal every marks on the paper.
You're too wicked, man.
Which is right.
Let us go. Let us go. Let us go. Watch me now. Do you recognize that this 4x squared cancels it 4x squared? Yeah?
Yes, sir.
Yes,
And you
sir.
recognize that this positive 2 cancels this negative 2?
Yes, sir.
All right. Still don't quint yet, you know. Don't quint, don't quint. Don't quint. So I'm gonna have now the limit. I'm gonna go back over here. The limit as h tends to 0 of -8, Ashanti, you see it now? -8 hx minus 4h squared. Was it who was it? Tice. You did well on the first part of it, Tice. On the numerator, I should say. You did well on the numerator, but you messed up the, well, I don't see the denominator, so I can't even say mess it up because I don't see it. Are you still with us, guys? You sleeping, or are you with us?
Sir,
I'm here, sir.
want to figure out.
Didn't finish it, sir. Hard.
All right, so I'm just rewriting that so you can see it. I don't want to miss any of the steps, so you can see what is happening. All right, look at what I'm doing now. In the numerator, I recognize that I have h's, so I'm going to factor out a h here, so I'm going to have that with a negative 8x, stock truth. You see that?
Yeah.
Minus a 4h, you see that?
Yes, sir.
All over the 2 x plus h all squared plus 1, 2x squared plus 1, and all of that is being multiplied by 1 over h. Watch this magic now. Watch this magic. This h down here, so no cancels with that h. You see that?
Yes, sir. We see that.
So as I can now apply the limit, I can know, because it's a once I cancel out that h, that's the time I'm going to apply the limit. Now as h tends to 0, what I'm going to have is negative 8x minus 4 times 0 all over, watch this now, 2 into x plus 0 all square plus 1 into 2x squared plus 1. That gives me negative 8x, stock truth, over 2x squared plus 1 times 2x squared plus 1. No, yeah?
Yes, sir.
Negative 8x over 2x squared plus 1 all square answer. It's a lot for the algebra. It's a lot of algebra. I'm not going around the bush. It's a lot of algebra. Yes, I know it's a lot of algebra.
Please zoom in, please. Back at the lower section and then scroll on a little bit. All right. Just for 2 seconds, I'm begging you.
Sir, 5 marks for that.
Sir. The question anybody posted for the people when they did the December 2017 exam.
Say it again, Papa.
Sir, the question anybody confused the people who did the December 2017 exam.
No, man. You see, it's a
Them do
first
it?
year. It's a first. No, man. I've had students in calculus 1 who I give them this question and then box it off, man. Yeah, man. You can box off this question quick and fast. But what the difficulty I have with this question is The difficulty I have with this question is they shouldn't give 5 marks. It's more like a between an 8 and 10 mark question. And the other thing is if you follow the steps, you won't go wrong. You notice for the denominator, when I found the LCM, you notice I wasn't interested in expanding what the LCM is supposed to be. I wasn't interested in the expansion of it at all. Why? Because if you expand it, the question can get longer. I'm not interested in the expansion of it. All right. What I'm interested in is just working on the numerator. So you need to make a notation whenever you get a quotient. That's what we call it. Whenever you get a quotient, Quotient, whenever you're given a quotient to differentiate from first principles, always remember that you're not interested in evaluating the denominator. At some point in time, I have to go work up the numerator. Why, sir? Because the numerator is going to contain the h. And that's how we're going to cancel out that h. Remember that h that I multiply by 1 over h? Multiply by 1 over h is the same thing as dividing by h. So we have to work out the numerator so that we can cancel out that h. So once we cancel out that h, start substituting the zeros in there. Once you cancel that h, just start substituting the zeros. Talk to me, or in the field. You can just work 2 more and call it a day. 1 of each.
So you can go over this question, but start it on a new page so I can just go through steps.
This specific question, but next one like the other ones.
Yeah, I was just about to say that, Demoy. Not this one again. What I will do is I can share this with you and you can write it out.
I write it out already, sir. I have the entire thing right now, but okay. The 1 over h, where you the LCM and you do the 1 over h, that part is giving me a problem.
All right. Come Lecarno. Can you find another past paper Lecarno with a quotient one on it from first principles, please?
Look, sir.
So just create one after that now, sir.
Say it again?
Just create a question after that.
I can.
Is it correct if you find one of them past people the one? So just create one of them.
Okay, no problem. If you trust my questions, I will do just that for you, sir.
Sir, it's not so much the calculation as much as it's the rule for it that is not sticking. Where the 1 over h, where you multiply everything over 1 over h, that is the part that I'm having a problem with. So even if you create a question, it shouldn't be a problem as long as I can understand that part.
Right, Lecarno, look at the screen.
I found one, sir.
Oh, you did? All right, so hold on to that.
1 over x squared plus 6.
You went share that one for homework. I pick up another one that I'm just going to walk you guys through. This one I don't have to type because I've already done it for you. You're going to share that one in the WhatsApp group for me, please, Lecarno. Or even share it in the chat, please, so that we can see it. Well, I can see it. And then so that we can work it together. So it says to differentiate f of x, which is equal to 5x minus 1 over 2x plus 3 from first principles.
Repeat that again, sir. So it is 5x
See,
minus
it's not.
1.
Oh, no man. See it here. It's on the screen.
Oh, okay. Thank you, sir.
Don't write. I will send the solution to you. I'm more want to see what it is that I'm doing. So just sit back and relax. So it says to differentiate f of x, which is equal to 5x minus 1 over 2x plus 3 from first principles. The formulation in red will always be the limit as h tends to 0 of f of x plus h minus f of x all over h. Watch
Sir,
me.
pause for a second. For that formula, is x plus h, not x plus h squared? Because I think I saw you have it squared in some of the questions, but maybe I'm not seeing correctly.
So
that is when it is squared.
Very good. Oh Lord, I just stopped share, right? Forgive me. That's very observant, and I am happy for the response from your colleague. I'm just trying to. All right, so this is where we started. You notice it is f of x plus h minus f of x over h. This is where the square come in. It's from the function. It is from the function. The square coming in from the function. See, this was 2x squared. That's why I end up having to square the f of x. I mean, the x plus h all squared. You see that?
Yes, sir.
All right. And this is what I want. You see something? Ask me. Right? So let me see if I can go back to where we are now. All right. Now, f of x plus h all squared. I mean, minus f of x over h. So in this function, f of x, in order for me to get the f of x plus h, anytime I see an x, I have to put the plus h beside it. So watch me. 5 is this. See our x here? So you're going to be x plus h. See it right here, so. Minus 1. See it here, so. But it is divided by 2, x plus 3. So it's going to be 2 times x plus h. See it right here, so. Plus 3, right here, so. Minus my f of x. So it's minus all of the original question. Alwyn was asking the question, sir, could I just put f of x right here? And sir said, no, write the function. Alwyn, can you appreciate it now, especially in this question that we write f of x, because we're not going to know what to do?
Yes, sir. I see it from earlier.
Yeah, man. That's what I want. Ask me the questions. Don't assume, because I can be able to give you clarity on what it is that you're doing. No, that is just numerator. Everything now has to be over h. Every single time we do the question, I have to put limit as h tends to 0, the limit as h tends to 0, the limit as h tends to 0. If you don't have it, you're going to lose mark. You don't have it, you're going to lose mark. Watch me. You see, I have it divided by h, but down here, so now I just say, yo, times 1 over h, you are starring. Because I don't want to confuse you, No, I confuse myself. So in here, so now, again, I'm going to ask the question, what is the LCM? LCM is all of this times all of this. Can you appreciate the LCM here now?
Yes, sir.
Yes, sir. It's much clearer in this example.
All right, cool. Now,
Wait, sir.
Green, I hear you now. Normally, to be honest with you, I wouldn't reach the division, the division one yet. Is because question one came into division one. In question two, I created a challenge. And I created a challenge because quite a number of you were getting the correct answers for example one, example two. So I said to myself, yo, the money, right? Where's Logan? Logan not at the class today?
And I don't think she joined class today, sir.
Okay.
Don't know why.
All right, let me just pause and say something. Let me just pause and say something, guys. You see, when I hear silence, my many years of teaching tells me that I am being tuned out, I want to now follow, I want to now learn. Just look at what, you may not be seeing what is happening, but just watch me. Just watch me. I'm going to send this off to you. Please don't write. Just look at what is going to happen. I'm going to send it off to you. So finding the LCM, I'm going to times this by this. See here, right here, so. Watch me. How many times can all of this go into the LCM? It has to be this number of times, the other one number of times. Can you see that?
Yes, sir.
So it's going to be 2x plus 3, see it right here, so, times what is up here. Then minus, how many times can 2x plus 3 go into all of that? It has to be this number of times. So it's going to be 5x minus 1 times this one, which is this, times the 1 over h. Then,
Sir, just a moment.
Mhm.
Can you go over that?
Can I do what?
Can you just go over what you just said?
How many times can 2 times x plus h plus 3 go into this denominator? I'm saying to you that it's going to go into the opposite one number of times. Follow me?
Following.
So it's going to be 2x plus 3 times, and this 2x plus 3 is going to be multiplied by this 5 times x plus h minus 1, which is right here.
I see.
And if you recognize what I've done, you recognize I have this line 2 times, don't? Anybody see that?
Yes, sir.
I'll just skip that. I'll skip that one and then move on here. Have I done anything with the denominator from I reach the denominator here? So have I done anything to the denominator, or is it the same?
It's the same.
Same. No trouble. It don't interfere with you. Leave it alone. Only work with the numerator. Why, sir? Because you see this 1 over h here, it is annoying me. I need to get rid of it. So it's 2x times 5x is going to be 10x squared. 2x times 5h is going to be 10xh. 2x times -1 is -2x. Plus 3 times 5x is 15x. 3 times 5h is 15h. 3 times -1 is -3. I'm leaving my middle sign here out for now. And then I do this multiplication first, and then I come back with my middle sign. 5x times 2x is 10x squared. 5x times 2h is 10xh. 5x times 3 is 15x. Negative 1 times 2x is a negative 2x. And a negative 1 times 2h is a negative 2h. Oh, and there's a negative 1 times 3 is a negative 3. I can write back all of this because I'm not changing anything here. Right here, so up to the 3, negative 3. And then I'm distributing this negative 1 over everything in this parenthesis here. So this negative 1 times 10x is going to be a negative 10x squared. Negative 1 times a positive 10xh is going to be a negative 10xh right here. Negative 1 times positive 15 is a negative 15x. Negative 1 times a negative 2x. When I multiply two negative numbers, I get a positive number. Again, negative 1 times a negative 2h, give me a positive 2h. Yet again, a negative 1 times a negative 3 gives me a positive 3. Still don't touch my LCM. I'm canceling out this 10x squared. Cancels out with this 10x. Yo.
Nah, so that negative 1 there, sir. What that jump in, sir? That always there?
This one here?
Yeah.
Yeah, man. There's a negative 1 in between always. Yeah. You remember, you know, it's f of x plus h minus f of x. So you always have a negative 1 in the middle every single time.
Noted, sir. Noted.
All right, good. So now, this 10xh cancels with this negative 10xh. This negative 2x cancels with this positive 2x. This 15x cancels with this negative 15x. The 15h, you have nobody to cancel with. So it is untouched. However, this negative 3 cancels with this positive 3. So all I have left is just a negative 15h plus this 2h over here. Have I interfered with my denominator? Yes or no?
No, sir.
I have not. But all this ugly something up here, so, is now reduced to now 15h plus 2h. I am going to factor out h. Like 15h plus 2h is 17h. So I can combine them. Now this h can cancel this h up here. So I can get rid of this 1 over h. See it here? So all I'm left with is 17 over the denominator. I won't read out the denominator again because it's long. The moment I've done this cancellation here is the moment I'm going to substitute 0 into the function. See it here? I'm only rewriting what is left here to show you. No, I'm substituting 0. So this number becomes 2 times x plus 3 times 2 times x plus 3. See it here, so? 17 over 2 plus x plus 3 all squared. I know this is heavy. Heavy even, it's a Friday, the end of the work week. And sir, come class, some heavy stuff.
Sir.
Go ahead.
Can you go back up to Jesus Monday? Yeah, go back up a little further. Start from the 2x plus 3. Let's start right there so that you are where your mouse is.
What about
just re-explain back this part for me, right? Here.
5x. All right. So what I did first was to show you how this thing works out here. 2 times x is 2x, and 2 times h is 2h, plus 3. So these two are the same thing. I just distribute this one over here. So quickly here, so 2 times x is 2x, 2 times h is 2h.
So you do your square brackets, you do your parentheses within your square brackets first.
Yeah.
And
And then
then
again multiply, distribute this over it.
oh, okay. Okay. All
So
right.
5x times 2x give me the 10x, and the 5x times the 2h give me the 10xh, and so
Yeah,
forth
man,
and so on.
that part I'm okay with. It was just that part up there. So I was
Okay, no problem. All right. So what I'm gonna do, not right now, I'm just going to take a little breather. We will get some cool off a little, and then I'm going to send you this workout in particular so that you can use a long weekend to go through it. Students, I don't know, they may give you a quadratic to differentiate using first principles, or they may be very mischievous and give you a quotient to do. If you get a quotient, I guarantee you don't look for 5 marks. It's about a 10 marker, anywhere between 5 and 10 marks, depending on the quotient itself. So it's going to be lots of marks. Just take your time and just do the stuff. All right, that's it for me. Any questions?
Sure, the exam is 20 multiple choice same way?
For the final exam?
Yes.
Yeah, man, 20 multiple choice, 4 essay type questions, and you select any 2.
2 words, I think
2
1 word
hours.
30 marks, right, sir?
And each essay type question values 30 marks. So they take paper marks out of 80.
The 2 hours, sir.
Please, press out early, sir.
Is it 2 hours? I don't think it's 2 hours. I think it's 3 hours.
No, sir. They said it gone back to 2 hours.
No, man.
It's 3 hours for labs.
Oh.
It gone back to pre-COVID times where you have 2 hours for exam and 3 hours for labs.
Well,
this is at 2 hours.
It means say, I forgot eat and breathe. Them something you say kind of box it off quick and fast. So we have no time for tricky jam. I forgot work fast. Yo.
Question. When we have the mid semester, which day?
Friday, next week Friday.
Multiple choice?
No, written exams.
This is not psychology or them something they're not. This is big people something we're talking about, you know. We don't do multiple choice.
All right, sir.
Anyhow, have a good one. Please do not revel too much. For those of you who will go out and splurge for the weekend, please take care of my calculus book with you.
Sir, please remember to send this example to the corner for him to share with everybody, please.
And the homework, sir. Send the homework.
Me now said no homework, you have homework in the past people. But Mr. Richards, you know, hear me say a while ago, so me go just take a little breathe and then have something pop up.
Okay, I need to go through it again, sir. Just
Yeah, man. I'm going to send it off soon.
Sir, the homework where they get Tuesday.
Yeah,
hear me, sir? The homework where they get Tuesday, they run through it in the class already?
Yes, I.
When sir come class, the first one, but not the second one.
What do you mean not the second one?
One of them, though?
Sure, it's never just the first one. We did work like, full time because the rain did make a keep on a lag out.
And the rest of it then sit down and don't defend me. Did I not do both questions?
Sir, you only did one, sir.
No,
when, sir. When?
Tonight.
Tonight. No, not those ones. Not those ones. We did do those ones.
No, man, choose a homework.
Some different ones, sir.
Okay, sir. I was late.
What are you talking about? Did I not do 2 questions tonight?
Yeah, sir, you did those ones, but there's 2 separate ones they're talking about, sir. There was 2 ones before that.
What, the piecewise functions?
Yes, sir. Yeah, the piecewise. You only did one of the piecewise, not the second one.
Oh no, that's a last week. When is supposed to do that and send and drop the answer on a chat? No, I thought you were talking about the
Yeah,
Oh
man,
no, sir,
shoot
you do
something
that today,
choose a
sir.
class, sir.
Them one of the easy man, so we did it.
Oh, okay,
But also I
okay.
know say I got
Actually
through it,
take
so
off
I'm
the
look
laptop
on the
for it.
record and I can save me up on the right track.
No, I didn't do the other piecewise question. No. So say that's if you're asking, I didn't do that piecewise question because I didn't remember about that one. But the two questions that I gave you for homework on Tuesday,
Tuesday.
I did those right. I did those two questions in class tonight.
All right, so that
All right,
one.
big up on yourself.
Yeah.
All right, sir. May I sign off, you know?
Me too.
Dean Shand.
Hello, sir.
All right,
Yes,
sir. All
is
the
it
best for the
possible?
weekend.
Is
Yeah,
it
man.
possible I could have a word with you?
Yeah, link me. Give me 5 minutes and link me, please.
Where? I should wait here?
No, link me in 5 minutes time.
Okay, sir.
Cool.